Hello everyone, today I'm going to talk about my final assignment where we have to do transformers and NLP from scratch. So this is my GitHub readme as you can see, and we have three parts in this. So the first part is like doing an inference with a pretrained classifier. So this notebook basically demonstrates how to use a pre-trained BERT classifier from KerasNLP for performing sentiment analysis without any training or fine-tuning. So let me go to the Colab. Okay, so as you can see, this is my Colab. I have already run it and we need GPU for this. So this is where I'm importing everything. I'm just checking the versions. And then this is where I'm getting the BERT classifier. So as you can see, I'm loading the BERT base to an uncased one. And then I'm taking two classes for the head. And then here I gave a few sample reviews saying positive review, negative review, and the mixed review. And then after that I created a batch of like examples based on that, so you can see that I passed these and a few other parameters. And then I'm also getting the rod predictions over here, and then these predictions I am giving them a class basically. If it is negative then 0, if it is positive then 1, and then I'm just printing the results of that and time taken, and just I'm printing all of the predictions. And then after that I'm demonstrating how we can how we can process a single input for real-time applications. So I'm just giving the single input saying I would recommend this movie to all of my friends, and then I'm just giving the times or start time, end time, all of that. And I'm giving the sentiment as positive if it is 1, or else negative. And then as you can see, the review and the prediction, all of that, I'm just printing these out. And then I'm just giving it how to like handle a longer text by breaking it into chunks. So as you can see, I've given a long review, and then after that we are splitting it into chunks. So yeah, here is the prediction part for the different chunks. All of that is done. I'm just getting the predictions and then getting it if it is positive, negative, all of that. Then I'm just comparing the different models over here. And then yeah, as you can see, we can also like load them and print. So let's go to the results that we got. We just got the versions. And then so if you see, the movie was fantastic, this is a positive. And then poor acting, all of that, uh, as you can see, all of that is done. And this is for the single input processing. I would recommend this movie to all of my friends. It says it's positive. And then even for the longer text, it was a positive response. So even though the score is less, we can still see that got the right prediction. And then this is where I'm saving it. So yeah, this is the test that I have based on our model. So this is a great example of how to use pre-trained models, and let's see if it is predicting right. Yes. So it is printing it as positive. So as you can see, this is all about the part 1. Moving on to the second part, here I'm doing fine-tuning a pre-trained backbone with KerasNLP. So this also I've used the BERT classifier on the IMDB dataset. So we load our BERT backbone via this particular line, and then also adding a custom classification head and fine tunes on tokenized IMDb movie reviews. So previously we just gave text of our own, but here we are using the IMDb movie reviews. And then tracks accuracy and loss, basically the testing or the validation graphs and all of that, training and validation. And then we also use early stopping and learning rate. Early stopping is nothing but if there is no increase in the accuracy, then we'll just stop, and then we'll keep that as the best model. Let me go to the Colab. So this is my Colab for that. So the first thing I've done is I've taken the sentiment dataset, mm, importing everything, and then this is the IMDb dataset that we have. Yeah, this is the IMDb dataset that is meant for sentiment analysis. So that is what we've taken. Then I'm using the BERT base to EN and uncase the same preset. I'm just defining a few parameters that I'll be passing later on. And then I'm just enabling the mixed precision training. This is where I'm loading the data set, preparing the data set, loading it, like giving it to the train and the validation. And then after that, this is what I'm doing. I'm getting the data set sizes, and then how many examples should I take. And then this is where I'm applying the caching and the prefetching for better performance. This is where I'm loading the pre-trained backbone. So as you can see, it taking this, and then if this is not present, then we're taking the BERT. This is a preprocessor where I'm defining a few parameters. This is where I'm defining the backbone, and then this is where I'm building the model basically. So the input, preprocessed inputs, backbone outputs, and I'm just checking. I'm just using the pool output if available and suitable, or else I'm just falling back to the CLS token from the sequence output. This is where I'm adding the dropout layer, and also the classification will be done here. This is the model, giving it input outputs, and then getting the model summary. After that, I'm doing the initial training with the frozen backbone, as you can see. uh, Calculating the loss, and the loss needs to be like in this particular data type, and then compiling the model over here. And then this is for the frozen, all of this is for the frozen model, and then this is the one where I'm doing it for the entire model. This is the optimization that I'm doing. And yeah, this is the learning rate scheduler that I'm using. So this is for the pre-stopping, as I already mentioned. So doing all of that. This is the optimizer part I'll be using. This is the compilation part, and then this is the I'm just this is the unfrozen backbone. So I'm just doing the training over here. These are a few visualizations that I have displayed, and this is a final model evaluation. So as you can see, this is the first step: loading the dataset, loading pre-trained backbone and preprocessor, building the model. These are all the layers in the model. Then training with the frozen backbone, fine-tuning the entire model. This is for the frozen backbone one. Then continuing training, and then this is a visualization. So this is where I'm testing on new examples. Like I've taken the same model as previously. This is what I'm doing. So as you can see, all of these are the uh, all of these are the tests that we have. All of them have like good results. So yeah, this is all about fine-tuning a pre-trained backbone with KerasNLP. Let's move to part 3, where I'll be building and training a transformer from scratch. So for this, I've used Keras, core Keras layers, and this all of these are implemented in this, and then it is combined into a custom text classification model, and the same trains on the pattern IMDB sequences, and it also includes visualizations, global average pooling, and the custom attention mechanism. So let me go to the part 3. So this is my part 3. So the first thing is imports as usual, and then I'm just setting a random seed for reproducibility. Then this is where I'm loading the data set. So this is the data set that I'm using from the Keras. I'm just setting the sequence length and the vocab size. Yeah, this is the conversion of all of the text. So basically we're just pre-processing all of the text and then creating the reverse word index, and this is the part where I'm decoding the reviews. I'm just printing a few training examples over here just to check. And then this is the function to pad the sequences. This is the padding part. And then this is where I'm converting it to a TensorFlow dataset for like better performance from the Keras. This is where I'm getting the train and the validation dataset. This is the uh, position encoding that I'm doing, all of this. And then this is the multi-head attention layer that I'm defining here. So all of this part is like all of the uh, parameters I'll be sent. And then this is the feed forward network that I'm doing, and this is the encoder Then we have the transformer encoder. So this is where we're doing the building part. So I am giving all of the layers that I want, setting the inputs and then giving the padding, and this is the transformer encoder that I'm defining, getting the all the outputs as you can see, and then this is the final Keras model that I'm creating. Then these are the model hyperparameters that I'll be sending later, and this is a transformer model that we'll be using. So as you can see, this is the model that we're compiling using the parameters and the optimizer, the Adam optimizer, and this is the defining callbacks part. Here I'm doing the training part, and then I'm just printing out a few graphs. Yeah, so this is a part where I'm doing the pre-processing for new text, and then so basically for this I have defined a function to pre-process, and then this is the one where I am testing. So as you can see, we have the model, pre-processing, compiling, accuracy, and all of that. This is the results that we have. So, and then this is where I'm saving the model. So yeah, this is all about the part 3. So we can say that we concluded all of the parts in this video walkthrough. So yeah, thank you.